Okay, this is from alcohol chapter. So you have to write down the product for the following reaction. A reaction is given. So let us say, let me write here. So this is from alcohol. So you have to write down the product for the given reaction. So you have this. This compound is given to you. If I treat this compound with OSO4, osmium tetraoxide, OSO4 in H2O, I am getting an intermediate, and the molecular formula of intermediate is C10H18O2. So this is an intermediate. Of course, this intermediate is isolabile. Now next, if I treat this intermediate with H2SO4, I am getting the product, and the product is having molecular formula C10H16O. C10H16O. So this is the molecular formula of product. You have to write down the intermediate and products. You have to write down the structure of intermediate and product. You can use whatever you know. So let me wait for 1 minute. You have to draw the structure of intermediate and the product. So let us call this as a product. Now this is a simple problem. You have to draw the mechanism. You have to draw the product one. I am not saying that you draw the mechanism, or you can derive the product using the mechanism. Let me wait for 1 minute. Now let us see. So first is osmium tetraoxide. This will basically give cis hydroxylation. So this reagent will basically add 2 OH cis side, 1 OH here, 1 OH here. So after the first, you see here you have how many oxygen added? 2 oxygen is added. This also helps me to understand there is a 2 oxygen that has been added. You see how many hydrogen has been added? 2, 4, 6, 8, 10, 12, 14, 16, and no hydrogen here, no hydrogen, 16 hydrogen we have. Now we have 18 hydrogen. So this means 2 hydrogen and 2 oxygen had been added. So 2 hydrogen and 2 oxygen has been added. This is possible only if I add 2 OH groups. So this also gave me enough hint. So this means I have to add this reagent osmium tetraoxide, that is a hydroxylation. So intermediate I will have, let me write here, I have to add 2 OH groups. So 1 OH group I have to add, and these 2 OH groups should be basically syn addition. So either both OH will be back side or both OH will be the forward side, both will be the front side, both will be the same. So this OH is a syn addition. So this is important. So you have to understand, or you have to remember, the addition is syn. Now the next mechanism, you see what has happened. If you see the molecular formula, C10 is there, H16, so this means H2O has removed. So if you see this mechanism, reactant and product, so I can clearly infer that there is H2O that has been removed, so minus H2O. So this gives me a hint. Thus in this step, there is a dehydration step. So one H2O has been removed. So I have to make a good leaving group H2O, and then I have to remove. So what I can do? So let me write here. So if I treat with H2SO4, that is basically acid H plus. So what will happen? So if I write, now in writing product, I can simply write here OH, and here I can write OH. Now if I add H plus, I will have something like this, OH2 plus. Now you see, this is a 1,2-diol. If you remember, 1,2-diol gives pinacol-pinacolone reaction. So this will lose H2O. So if this loses H2O, I will have something like this. I will have here OH, and there is a plus charge. Now what I can do is, I can either shift. So there is no alkyl group here, so I can, though no hydrogen here, so I have only one option. I have to, so because in pinacol-pinacolone reaction there is alkyl group that migrate. So this carbocation will be stabilized if this alkyl group migrate. If this alkyl group migrates, so now we will have, so you can write here. So I will have this ring, so the 6-membered ring, and then I will have this carbon is attached to it, so 1, 2, so this carbon is here, this carbon is also here, so 1, 2, 3, 4, 5-membered ring. So here I will have a 5-membered ring. Are you getting or not? So this is a 5-membered ring here I will have. Now here I will have, so this OH, there will be a positive charge. Now this positive charge is resonance stabilized, and that's why this carbocation forms, because of this resonance stabilization. So you make a resonance stabilized molecule, so you will have double bond OH plus, so you will have here, and a 5-membered ring you have to make. Are you getting or not? So this is basically 5-membered ring. So if you have confusion, you can make something like this. So this is a 5-membered ring. Are you getting or not? I can make, so this is the resonating structure for this molecule. So this is a 5-membered ring. So this means in the next step I can lose H plus. So I have to add this is a 6-membered ring, and then I have a 5-membered ring. So let us make slightly in a good way. So this is a 5-membered ring, and I have OH plus, oxygen has a positive charge lone pair, so I can lose H plus. So if I lose H plus, finally I will have this, and there is a 5-membered ring. Now double bond O I will have here, so let me put double bond O. So double bond O I will have here. So this is a pinacolone reaction. So you just write down the product. We'll discuss the next problem then.